Good morning. I'm right here with Mr. Robert Houtman, founder, president, CEO of QUAD. Good morning, Mr. Houtman.
Hi, sweet. How are you?
I'm doing great. So where are we heading today?
Well, on our way to San Francisco, you got some business and get a chance to, 9:13. So it's a beautiful day in the Bay Area. On place to be. Okay, go back over this bridge. We'll see where that's being built. You know, the addition to this Bay Bridge. And every time I go over, I think about all those jobs going over into China, building the steel and what have you. What time is it?
Right, exactly. I know.
All that engineering could be done right here. You know, putting some apprentice schools right in Oakland, like, you know, they have the Cypress Mandela for construction. You should have it for engineering, science, math, and all of that. QUAD. Okay, let's go.
So tell me a little bit about what made you come up with QUAD.
Well, I'll tell you. We are in a war. Every bit as destructive as any, conflict we've been in the last 1,000 years. And the situation being that the deterioration that's rampant, the cancer that's rampant inside these inner cities is just only going to get worse. So, to me, the only way to remedy this situation is with math and science. World War II was won. That war was won because of math and science. And like I said, we're in a war now, and we need generals. No two ways about it. Educators, but people that have a way of getting across to these young people, the alpha males, the hardcore males, because they're the ones that are in these inner cities. And believe me, the inner cities, as you see on TV every day, every weekend, you see 30, 40 murders in the big cities, Los Angeles, Chicago, and what have you. It's only going to get worse, and that's going to spill over. It is spilling over into the so-called suburban environs now. Heroin now is more rampant in white suburbia than it is in the inner cities, ethnic areas of Hispanics and African Americans. It's terrible. So QUAD, I developed QUAD. Engineering and nuclear engineering is my background, and for years I worked in it. And I was out here in 1972 with Bechtel in the fast flux test facility. Here again, we don't build nuclear power plants anymore. I was fortunate to work on the first fast breeder reactor. It was called the Fast Flux Test Facility, and it was designed and built by the Bechtel Power Corporation. And it was going to be set forth in the Atomic Energy Reservation up in Hanford. Well, that is in cold storage today. It was a test facility. It was never meant to generate any real megawatts of commercial electricity, but it was a project to go ahead and explore the value of fast breeder reactors. And it was a major project. Right after 3 Mile Island, all of that died, of course. But now we're in a situation where the infrastructure is just coming apart. We definitely need nuclear power. That's the only way to go. And so that was my experience, of course. Then in the automotive, when you and I met years ago, we got into engineering and automotive, and the automobile is really a technological marvel now with all of the microprocessors and what have you. It's a scientific entity in itself. Now, QUAD. It's always been my contention that math and physics all should be taught together, but math, the elements of math, geometry, algebra, trigonometry, and calculus should all be taught as one unit. So you do something here algebraically, and then you put it into the mode of motion and change, because everything in the universe is motion and change. We're driving, so this morning I wanted to talk about this because we're driving in motion. I love movement. Everything is movement. I can go into a first grade classroom and talk to the youngsters and say, everything is moving. Right now we're traveling at 18 miles per second on our sidereal journey around the sun, And of course, so at the end of the year, we have traveled 567,638,000 miles. So you're really not a year old. You're so many millions or billion miles old. So you start to put it in perspective of movement, and you get them to say, hey, everything is action. Everything, we're moving. Nothing is static. And from that vantage, we start talking about numbers and how numbers move. And and how they interact and they describe a phenomenon or a situation. It's a language. And from the aspect of young people, African American, Hispanic, people of color, we tend to see things differently as far as we learn spatially. School systems never understood that. They have situations, they lay down this criteria which has never been effective. I don't know how they ever put arithmetic into the equation. Arithmetic was a form of ciphering for building trades and what have you. Really, the all-numbering system is algebra. Algebra is an Arabic word, And it's funny because I remember way back in the third grade, it was the fourth grade or something. I know I got the ractan. I said, as the teacher, I said, well, why is it that we deal with Arabic numbers, but we never talk about Arabs? Why is it we talk about Arabic numbers, we never talk about algebra? We had a Encyclopedia Britannica, so I knew about algebra and that. She told me to sit down, And so you can't come across like that with young people. They have they're bright people, especially at that age. You got to give them information. They have knowledge, and what they want to do is get some confirmation, some validation. They put it out there. You got to answer that. So anyway, so the all-numbering system algebra should be taught in kindergarten. A young person, I can go into a kindergarten classroom, and I can stand at a position right here. And I can mark off on the floor. This is north, this is south, this is east, this is west. I'm standing right here in the crosshairs center. Now, if I go to the left, I'm going to go 2 steps or 3 steps to the left. I'm just as positive in my movement, I'm going to the left. And if I go to the right, I'm just as positive in my movement, I'm going to the right. Basically, I'm trying to put the underlining aspect. There's no such thing as subtraction. Nothing is ever subtracted from the universe. Never. And it's funny because they never really explain this, but if you take 2 negatives and you multiply it, multiplication is a degree of additive, right? It becomes positive. So wait a minute. You tell me that, okay, so everything's really positive motion. Okay. Nothing's ever subtracted. If I tell a kid and sit down with this youngster, he's bright, they're all open to everything, you get 5 blocks. I take 2 blocks, I put them over here. 3 take away 2. What do I have left? Still got 5. Just 2 has been displaced over here. They didn't just go away. So likewise, I'm saying there's no such thing as subtraction. So I go to the left. I go 5 steps to the left. Now I'm in the negative side. So I'm at -5. I'm going to turn around and go 2 directions to the right. I'm just as positive in my movement, but now I'm at -5, I go +2, I'm at -3. That's what they should have been teaching in the first grade. It's not subtraction, it's adding. I don't know if you want to, unlike signs or whatever, but it's positioning. And so a young person can understand that in kindergarten. So now we've taught the basics of just algebra, right?
Right.
I can also tell a youngster in the first and second grade, if I'm standing here at 0, and I'm going to call this plane that I'm standing is the x-plane. I don't want to use the word abscissa. Let's just keep it simple. X-plane. And this is the y plane. But I'm at the crosshairs, I'm at 0. So in this case, x equals 0. Now, if I go to x equals 5, if I go to some other point on x, in order for me to get there, I would have had to move. That's just common logic. I would have to have, if I'm here and I'm there, if you see me here, I must have moved. In order to move, I had to have some rate of speed or velocity. So there had to be a velocity involved. So if I went from 0, x equals 0 to x equals at some point, x equals 5, I had a movement. I had a change in x. And that meant I had to have some velocity. Great. Time is constant, so I had to have some element of time. So the change of x is delta x. related to the change in time, in relation to change of time, delta t equals v. Delta x over delta t equals v. So the change in x equals v. So I can then say dx over dt equals v. That's differential calculus. You mean to tell me a second grader couldn't understand that? Let me go on further. If I'm change my acceleration, or if I change my speed, I'm moving, and I go a little faster at some point on x. So that means there's been a change in my velocity. So dv over dt equals a. Acceleration calculus. Differential calculus. Once they see that, we're off and running. You mean to tell me I gotta wait till I'm in the 10th grade? Young people's minds are not even thinking about that. They've been so diluted with this baloney of all these different factors and postulates and functions and this, that, and the other, you know. You know, in computer, giga, you know, gigo, you know, garbage in, garbage out. So y in the y plane is also equal to function x. I have some function of x, whatever I put into x, like 2x, y equals function x equals 2x plus 4. fx equals 2, function, you know, function 2. 2 times 2 is 4. Plus 4 is 8. So y, or function 8, y equals function x equals 8. But algebra, the other thing, all this, we understand proofs. We understand the movement. Let me just take 2x equals 4. Now, the logic is that, you know, whatever you do to one side of the equation, you do to the other. I can do this in kindergarten. Kindergarten, we can talk about this. The equal sign is the fulcrum, right here. Boom. Anytime I go from one side to the other side of this equal sign, I change sign. So if I'm at a plus 2 on the right side, if I move that 2 to the left side, it's minus. If it's minus, goes to the right side, it's plus. Simple as that. It's a linear equation. Linear equation being a straight line. 2x equals 4. I want to solve for x. Now, this has been proven, so we don't have to worry about the proofs, but in real complex or long equations, you can't. I want to divide both sides by 2. So if I divide both sides by 2, which is 2 divided by 2 is unity, 1, and then you got 1 times x, and then 4 divided by 2 gives you 2. So x equals 2. Why put all that, bring all that garbage in where I got to divide this by that? Let it move. You have a coefficient and a variable. The variable is x, the coefficient is 2. So I got 2x equals 4. X is the variable of focus. X needs to be by itself. Get this thing off my shoulder. Get out of here, 2. Just let the 2 swing under. Boom. Get off me. Okay? Young people can understand. Just let the thing move. Just get the x by itself, let it loop under the 4, you got 2x equals 2. It's movement. So now you can do all of these things and you can move it back and forth, back and forth. On that basic equation, once a youngster makes ground with that, they're off and running. So, the other thing, analytical geometry. Triangle. The old Pythagorean theorem. And I hate to go into this, but I must, you know, because you get youngsters to start reading about math and science, the histories of math and science. You mean to tell me the Egyptians didn't know how to square the triangle? You know, they got the pyramids been standing 15,000 years, one they call Khufu or Cheops, you know, whatever. So, the whole Pythagorean theorem is a squared plus b squared equals c squared. What does that mean, man? You know, I know that a triangle basically sits inside a circle. And the other thing I would want to speak of, when you talk about math and science, geometry, physics, you're talking about the Earth initially, and then other orbs, planetary orbs, in relation to the Earth. And the galaxies, everything is moving. Everything is moving. In a circle. I like circles. At MIT, they talk about circles. Everything's circles. Now, That being said, that the word geometry. Let's talk about the word geometry. Geo means the earth. Metry means the measure of. Geometry is the measure of what? The measure of the earth. Very simple. So we take some cross section, and I think about a circle, and then I make a segment on the perpendicular side of the triangle, sits inside the circle, and the radius arm is it describes the circle. So then, really, it's really on x, y, and r is the radius. So we say x squared plus y squared equals r squared. That is really the universal formula there. You know, you can say a squared plus b squared equals c squared, but why you call it a Pythagorean theorem? There's no evidence that Pythagoras ever existed. I know I read Herodotus' histories. He said that they're all plagiarizers. But anyway, it's really called the substratum underlying analysis of the right triangle. So the minute a young person understands that, as soon as we talk about the triangle and we say x squared plus b squared equals c squared, or x squared plus y squared equals c squared, x squared plus y squared equals r squared, or a squared plus b squared equals c squared, we're talking analytic geometry. Boom. We put that in the equation early on in the equation of learning. And what we'll do later, and I want to show this pictorially, is about unity. When you talk about unity, you talk about unity, you talk about unity, you talk about unity, you talk about unity. Unity is one. Unified, you know? One. And mathematics is always about unity. 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 So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm really talking about 1 over 1, 2 over 1, 3 over 1, 4 over 1, 5 over 1, 6 over 1. So if I take 1 over 1 and I multiply that by 2 over 2, I'm really multiplying 1 over 1 times 1. Or 1 times 2, 1 times 2, 2 over 2, 1. And so everything starts off in unity and has to have movement. And I will show that pictorially. And it's so easy for youngsters to grasp. I think it's so important. And so getting back to the war, this cancer, the only way we're going to turn this around, and rest assured it has to be done in the inner cities. You know, we have to come in with a Trojan horse. I call it the QUAD-mobile, or the math quad-mobile. You know, math quad in motion. The quad comes from the quadrants, or the 4 elements of algebra, geometry, trigonometry, and calculus. We bring this big mobile vehicle in. Beautiful, the blue and the white. And we have the integral sign, integration, and all of that. Bring that in. We pull up the basketball court. Come on over here, I got something for you. You want to see what some real power is? You bring that in. You bring that in. Schools are useless. These public schools, the cesspool, it's going, you know, the condition in these inner cities and the public schools, forget it. It's not what it was. It'll never be what it was. And, you know, they call these people nerds. If I look like a nerd, I'm a warrior. And I'll tell you something. Math and science is for warriors. It's a strong entity, you know? And we need generals to teach this. We need generals. Math quad needs a math squad.
But I do like the idea of going into the inner cities, whether it's going into the schools or going to, you know, the community centers or whatever, where the kids are that are not, exposed to someone like yourself, you know, that could take these, because that generation is like a lost generation.
It's the only answer. It's the only answer. And you want to get the alpha males. The dropouts, who cares? They're the strong ones. They're the ones that have influence. You've got to get these alpha males. You get them involved in this, you know, and start talking about real power and knowledge. Imagine them being able to solve problems and work problems in physics and algebra and calculus. That'll change. It's a divine science. It'll just change them in general. Their whole spirit will change. And, you know, God speaks in the language of numbers and science and the universe. Just look at it. Look at it. but like they don't hear it. They don't hear it. They don't hear it presented to them in a way that they can understand it.
No, right.
Look at them. Everything. The whole body is physics.
Yeah. Which is why they need math quad. Which is why you need the mobile to go into, these communities so that they can start to hear it, so that they can start to, have something to propel themselves forward.
Yeah. Well, math and science. I grew up in drum and bugle corps, rudimental drumming. Rudimental drumming was excellent because it demanded a certain level of devotion, hard work, and excellence. Execution. And math and science, it's about execution. And then about learning about God's beautiful universe, the total universe. Being able to plot the stars. This opens up so many avenues. But young people in the first, second, and third grade, imagine this. Imagine doing calculus in the third grade. By the time you get to the sixth grade, you're actually equivalent of doing work that you would be doing in your first year of high school. First year of college. So then by the time you get to the ninth grade, you're doing work you were doing if you were doing graduate school work. So by the time you get out of high school, you're ready to go into your PhD. That's when we're going to catch up. Mm-hmm. And our young people are bored to death. How are you going to go in and teach, equivalent to Dick and Jane with math and arithmetic and this boring thing of just throwing algorithms around, not solving problems, not talking about the real deal, talking about everything. Just take a youngster, stand up. This is your higher self, the middle, this is your center, and you got your lower self. Bottom movement, the denominator controls your movement, where you go. And, use that as aspect. The body is nothing but a machine. It's a beautiful machine, Of course, it has a spiritual essence that's fired into it, But it's physical, the fluid flow, everything. That's fluid mechanics, blood flow, heartbeat. Inhaling, exhaling. That's nothing but amplitude, wavelength. You breathe in, you breathe out. If your breathing starts to get slower, you get wider wavelength, less amplitude. If you start breathing, you get the ding, dead line. This all represents a sine, cosine. Make it come alive. That's what we're going to do.
I love it.
That's what we're going to do. Here, I'm going to get ready to go over this bridge. And every time I go over this bridge, how many youngsters understand we're going over this bridge? If you go into a kindergarten, you talk about the bridge and all the stresses. It's called strength of materials. But all this movement, there's all these forces and moments around this bridge. It's not just standing there. This is a suspension bridge. So all these things have to take into an allowance. Movement. They have to allow for movement. Seismic. All of these different things, man. All these elementals have to be put into the design of this bridge. Yep. And we get into, infinite series and matrices. How we know these youngsters sitting in the inner city right now, thinking about, I'm going to go do some damage with this Roscoe today. I'm going to rob somebody. He may have the elementals in his genetics to cure cancer, to come with all these other kind of things, just to make the world a better place.
But it's all about exposure.
It's all about exposure. It's about strong exposure.
Yeah.
It's about coming in there. Math and science is powerful. It's just powerful. Look what they did with the bomb. Okay? And everything we enjoy today, quantum mechanics, the sub-level subatomics, everything we enjoy today is because of math and science. And so, I think it's the only thing. It's the salvation of this country. But my concern is the young people. My people, best the young people of color. Because if we do not educate them and get them impassioned, then, there's going to be a total revolution of destruction. You're seeing it now in the inner cities. It's just going to go and exponentiate upon itself.
Okay. And we'll pick it up on the other side.
Yes, we will. Here we are in West Oakland. This is Oakland Technical High School. We're on Broadway in West Oakland. Unlike the high school that I went to, Boston Technical High School, they really don't teach a lot of technical science in here. We had PhDs teaching at Boston Tech. It was just a phenomenal school. Things sure have changed. Beautiful building. nothing technical being taught. Excuse me. Okay, I'm gonna go and talk to some of these youngsters and see what they're going to do here. You know, beautiful building. Do you go to school here? You go to school here?
Yeah.
What grade are you in?
I'm about to be a senior.
A senior?
Yeah.
I'm Robert.
Hi, Robert. I'm Nicolette.
Nicolette? Jessica? What are you studying?
What, like during summer school?
Well, what are you going to be taking up in the 12th grade? You're going in your senior year.
Yeah.
You're taking calculus? Are you taking physics?
I already took it.
Yeah? How did you do?
Got an A.
Got an A? Well, how come you're not continuing physics? What do you want to do?
I want to be a broadcast journalist.
You're going to technical school, want to be a broadcaster? Go to journalistic school. You want to go to science, you want to be in the science. Listen, I'm putting together a thing called Math Quad. If I came in here, you're going to be gone. What grade are you in? You're going to be a senior. Say we had a bus that came in this big, beautiful mobile vehicle and said Math Quad. And we had computers, we had everything. We were going to talk about real physics and science and really break this thing down. Would you love that?
I don't know.
Well, tell me about the school. What subjects did they teach you?
Math, English, science.
Math? Calculus?
Yeah, they have calculus.
No. Did you take calculus?
No.
I took pre-calculus.
Did you?
I took pre-calculus.
Pre-calculus? What is that? Algebra and geometry, trigonometry? Did you ever take them all together? Did you ever take algebra, trigonometry, geometry, and calculus all at one shot?
No.
So, when did you take algebra?
Algebra 1 or algebra 2?
Well, either way. Algebra 1 and algebra 2.
Algebra 1, I took 8th grade.
Okay.
Algebra 2, I took 10th grade.
Okay. When did you take calculus?
Pre-calculus
Last year. So, you're talking for almost like 3-year lapse, right? So by the time you got into the pre-calculus, you forgot a lot of the algebra, right? Yeah, see? It all works together. But, journalist, huh? What do you want to study? If math and science really opened up to you, you know where the jobs are today? We're in a technocracy. You know what a technocracy is? We're living in a technocracy. It means that science rules the world. Everything that you see today, your cell phone or your smartphone, that's all engineering and science. Eh? Get paid big money doing that.
That's not really that's not my passion. That's not what
I understand that. So, psychology. What about psychiatry? Then you could be a med doctor. You know, and let's say psychiatry, you still have to do some kind of analysis and things of that sort, right? Some type of statistical courses even in psychology, right? Math, algebra, calculus. It's been a pleasure talking with you, okay? Just wanted to visit the school. How are the teachers? Are they aggressive here? Or do they teach? Or do you find that problems?
It depends on the teacher.
It depends on the teacher.
We have some good teachers, some horrible teachers.
Some horrible teachers. Now, do the children get excited when they come in and they get you moving?
Depends on the class.
Depends on the class. Now, you studied physics, right? Did they ever tell you that we're traveling really fast, like a bullet? We're traveling faster than a bullet. The Earth is traveling at 18 miles per second. Did you know that? And where is it going? Around what? Going around the sun. So how many miles does it travel a year?
There you go right there.
It's a sidereal journey. 567,638,000 miles. So when you're a year old, by the time you're 2 years old, right, you traveled over 1 billion miles. So you're 1 billion miles old. If you think like that, you'll never get old. Think about that. If you put your mind into movement, right? Pleasure talking with you. What's your name? Huh? What is it? Richard, what do you study? Richard, I'm Robert.
I'm running here for summer school for intermediate algebra.
Intermediate algebra?
Yes.
Now, what do you think about studying algebra, geometry, trigonometry, and calculus all together? Because they really go together. Don't you think it would be an easier way to see this thing and move together? Because algebra is just manipulation of algebraic principles. But then again, calculus is motion of change, which is the real universe, right? If you saw it all together, then you can get the whole picture. It's like an assembly plant. The finished product of the automobile. If you can see it all coming together, you get an understanding how it all works in unison. And grasp. How are you doing with the algebra?
Doing alright.
Just all right, huh?
It's easy right now, but I'm sure it'll get difficult next week or something.
If a unit came around, we call it math quad. I'm putting together called math quad. Math quad means 4 quadrants of algebra, trigonometry, geometry, and calculus, all taught as one unified whole.